A nyní mi dovolte uvést našeho dalšího řečníka, kterým je pan profesor Timothy LaSalle z California State Chico University, kde je spoluzakladatelem Centra pro regenerativní zemědělství a odolné systémy, jak zde čtu. Je to uznávaný americký expert na regenerativní zemědělské systémy. Působil jako ředitel Rodale Institutu, o kterém jste možná slyšeli, Bioorganic. Zároveň působil v centru Alana Savoryho, to jste možná zachytili, tento institut, co je ve spojení s holistickým managementem, s regenerativní pastvou. A je emeritním profesorem Kalifornské polytechnické státní univerzity. Pan profesor bude mluvit v angličtině, ale má s sebou tlumočnici, takže vy se nemusíte o nic obávat. A já bych ho tímto rád pozval na pódium. Prosím pana profesora Timothyho.
Good morning. I am sorry I do not speak Czech, but it is indeed a pleasure to be here with you today to talk about a subject that could literally save the world. So I'm a farmer, I'm a scientist, and I'm actually a committed human. And I refuse to retire until we figure out how to solve our problems together. I had the opportunity to work in Africa with Howard Buffett with smallholder farmers. And he gave me what he promised was the best, worst soil you could do your experiments on. I had to learn how to do no-till, I knew, because I had to change how we cared for the soil. And I set up a system with no outside inputs. I began to learn there, and now I understand better what principles really help feed the biology, like our last presenter just talked about. And I knew the reason the responses were so great on what was phosphorus-poor soil was because of the biology. So I'm going to ask you a question, particularly you farmers. What three principles will feed this biology and make a productive regenerative system? What are the three basic principles we have to do in farming? And I'm not going to say what they are. At the very end, we will check. We know that there's about 55 years of topsoil left at the rate we're degrading and losing it around the world. And upper left is the soil I was farming in Africa. The field right next door was only disked once, and the rainstorm came and washed it away. You see, I was farming sand. And we were working with some of the ministers in Burundi, Africa, and every square inch of soil in the upper right was tilled. And most of that soil was ending up in the Aswan Dam. So we know we have to stop tillage as much as we can. And this is an example from Ghana, where in these trials that I was helping with, the cowpeas in the upper position was farmed for the first year with no-till, and in the lower was tilled. And with short rainfall, there was a crop failure where it was tilled, where there was food security with the no-till. That was the only difference in those two plots. I'm going to share with you some numbers, like on carbon capture, that many farmers will say, well, I just can't do that on my farm, because I don't have that kind of soil. One of the things is I think we're thinking about our soil wrong. This tree didn't make a very good decision on what kind of soil it chose, did it? There's no soil. How did it grow? It's not so much the mineralogy of the soil we're learning as it is the life of the soil, the biology. And what we're learning is the importance, particularly, of the fungal communities in that whole mass of diversity of the biome. The only reason that tree grew in the rock was because of the biology. When I returned to the United States from Africa, I met Dr. David Johnson, who had developed this Johnson-Su technology. He helped me understand the complexity, the interrelationships, and all of the signaling and communication that goes in to a healthy soil biome. It made complete sense to me, and I've trained probably 100 farmers how to build a bioreactor to inoculate their soil. The cover crop on the left here was inoculated. The cover crop on the right, just compost was used. The quince fruit on the right, it's a quince. The one on the right comes from commercial production. The one on the left was with the biology of Johnson Su. However, at the university, we've run 4 trials on 4 different farms in Arizona and California on 4 different crops, and we received no results positive from Johnson Su. We have some theories about that, but let's just go to some practical understandings of how the soil is going to work in a natural condition like your farm. All that biology is going to come to your farm for free through the air, from the forest, from somebody else's field, from the animal yard. It's going to come for free and fall onto your plants and fall onto your soil. If you have the right system in place, you can feed all of that life, that biological life. And growing up on a farm, I was used to seeing roots like this. And as I farmed, I saw roots like this because I used fertilizers. And they're bare. We want to see roots like that, what we call dreadlocks, with sticky, gooey substance on it sticking to the soil. The first time I saw this was in my wife's garden in Africa when I pulled the weed out. And I saw that and I said, that must be disease. It was sticky, gooey stuff on the plant. And here's where the sticky goo comes from. It comes from the root exudates, sugars and carbohydrates, wanting to feed all of the life of the soil. And in feeding the life, we can, this is called the liquid carbon pathway, as coined by Christine Jones from Australia. It will create more biomass than the compost you want to bring in oftentimes. There'll be more carbon in the life of the soil. And that's how we can do no outside inputs, is build that life. And I want to focus more heavily. We need it all in there. A lot that the previous speaker talked about. All of that life needs to be there. But the fungal communities seem to be particularly important. And most of our agricultural soils are now bacterial dominant. And we need them to move to fungal dominant. This is a depiction of mycorrhizal fungi that, when properly associated, can expand the root surface area 1,000 times in the soil. That means we'll capture more solar energy from photosynthesis to feed all of that fungal community, which is going to be resilient carbon in the soil. And that mycorrhizae will reach out and find nutrients and transport water and demineralize and make other nutrients available to the plant that otherwise couldn't work. And Ingrid, thank you for translating this for us, but here is a demonstration in Florida where they inoculated corn with mycorrhizae and versus no inoculation, and you see the difference in a drought year. So think about reaching out to find droplets of water all through that soil that just the roots couldn't do by themselves. But to feed the biology in all of it, we need diversity above the ground. So we need multiple plants with different root architectures and different exudates to feed the different organisms. And here's an example that Christine Jones shared this picture with me. In the foreground is a crop called triticale that's failing when there was a rain-short year. And on the right, you can see the same grain in a multi-species planting doing very well. Same amount of rain. It's the biology. And it was being fed with the diversity. And what we're finding in our research is when we have a diversity, like planting a winter cover crop that's multi-species, 6, 8, 10 species, we see the shift from a bacterial-dominant soil to a fungal-dominant soil, and we see then the responses in the soil and in the crops. And what happens is the soil bulk density changes, so it becomes more porous with all of the attributes of water percolation, air movement, health of the plant. And we know tillage destroys all the advantages of creating those spaces where the fungi will glue particles together and leave the air spaces. So that's where the no or minimum tillage is crucial, and then building this biology to create this healthy, less dense soil. Also, we see soil aggregation greatly improve so we don't lose the soil. and that's caused by the biology. We see a dramatic shift in soil color and texture in the first year. And here's the great news about climate change. Gabe Brown in the United States claimed he got 11 tons of carbon per hectare per year. That's about 40 tons of carbon dioxide per hectare per year.
Sorry,
Gabe Brown was the name. He got about 40 tons of carbon dioxide per hectare per year. So we entered on Howard Buffett's farm in Arizona, we entered in 2019. He was slowly gaining carbon in his soil over time with no-till. And we added multi-species cover crops, and you see how it jumped. And it matched Gabe Brown's without the incorporation of livestock. And in Wilcox, because economics matter to farmers, in the pinto bean year rotation, it was the same yield with 0 fertilizer versus 15% versus 100%, but the profit was not in 100% fertilizer. In the very first year in that field with planting multi-species cover crops, the 100% fertilizer was the least profitable. It was 15% was the best and the no fertilizer. That was in year 1. You were better off to use no fertilizer than to use fertilizer. I know a speaker following me will talk about agroforestry. My wife and I just came back from India. This is cash crops planted interspecies, multi-species, gaining the same carbon. Problematically, where we use equipment, you can't harvest this way. But there, with a lot of hand labor, they could. They're capturing carbon. They're increasing photosynthesis on that land. And as Christine has said, if we increase photosynthesis by only 5% on this planet, we'll draw down our legacy levels of carbon dioxide. And we know we can graze differently and change landscapes to one that captures solar energy and builds biodiversity and makes ranchers profit. My conversation only has 4 more hours, except they say I'm out of time. What are the 3 principles? Tell me, somebody, tell me, what are the 3 principles that we need to, how we have to work with our land? No-till. What's the second principle? Biodiversity. Multi-species, we got to feed all of the life below with diversity from above. So we have to get it through the cover crops or interplant our regular crops. And the third one is more subtle, but I'll share it unless somebody wants to offer something. It is keep a live root in the ground 365 days a year if you can. That means you're feeding life all the time. And you're capturing photosynthesis. Even if it has to dig its way out of the snow, the life is still being fed. So keep a live root as much as you can to feed the soil. And together, with love and compassion and generosity to the world, we as farmers and scientists can actually help solve the critical issues facing humanity and life on this planet. It's soil loss and climate change. So I look forward to working together with you to accomplish just that. Thank you very much.
A já bych chtěl moc poděkovat panu profesorovi Timothy LaSalle za tuhletu globální perspektivu, globální úhled pohledu, kde slyšíme zkušenosti z několika kontinentů. A tady bych mi chtěl možná zdůraznit, že právě, jak on říkal, často přicházejí farmáři, říkají, ale na mé farmě ta je úplně jiná, tam to nepůjde, tam tohle to neplatí. A potom slyšíte lidi, jako je on, kteří sbírají ty zkušenosti v Severní Americe, v různých klimatických zónách, v Africe, v Indii. A máme zkušenosti z Evropy a různých klimatických částí Evropy. A zjišťuje se, že ty základní principy, které zde zmiňoval na konci, ty fungují všude. A není tak podstatné, na jakém typu geologie, mineralogie hospodaříte, pokud najdete způsob, jak obnovit biologii. A já teď přestanu mluvit já a chtěl bych zároveň dát instrukce pro otázky. Takže za prvé, my tady budeme mít 2 kolegyně, jedna a někde druhá budou běhat z mikrofony, takže si připravte otázky. A zároveň bych chtěl tímto vyzvat diváky, kteří nás sledují online, že vedle YouTube máte chatbox, kam můžete posílat své dotazy a mně to sem pak přijde do kapsy. Zkusím to stihnout už k tomuto řečníkovi. A samozřejmě vždycky je málo času, takže konverzace pak mohou pokračovat o přestávce. Tak, první otázky. Pokud ne, tak vystřelím já. Tamhle vidím ruku. A já ještě položím jednu otázku. Jakou roli hraje spotřebitel v regenerativním zemědělství?
The role of the consumer is simple. We must educate them because Wendell Berry once said that eating is an agricultural act. I would like to take liberty with Wendell's quote and say, eating is a climate act we perform 3 times a day. So we must insist that the food, either if we're buying it directly from the farmer or from a company, is grown regeneratively. And I like what Carboneg is doing, is trying to actually verify that carbon is coming back to the soil.
Perfektní. A tamhle máme otázku.
Tak já bych se chtěl zeptat pana Timothy na ten systém no-till, jak tu zaznělo. Jestli to pro něj skutečně znamená do té půdy vstupovat pouze při tom setí, anebo jestli jde pouze jako o bezorebný systém, ve kterém ale můžu použít nějaký povrchový kypření.
We think minimal. I do that on my farm, minimal. I don't have a no-till seeder. It's very costly. And this is the big challenge for us as farmers if we have small farms. How do we afford a no-till seeder? So I use a light disking to put my seed in. And it functions exceptionally well. It's better to do no-till, but yes, it still functions. We just had a storm with 4 inches, well, I don't know how many millimeters that is of rain in 15 hours. We had this much rain in 15 hours, and I had no erosion with minimum tillage and good aggregation. And maybe farmers can create a collective a cooperative to own no-till equipment and share it.
So otázky, omlouvám se. Jedna otázka tamhle. Prosím mikrofon. Ano, jen jsem to chtěl za záznam. Jestli poprosím mikrofon, jinak já zopakuji otázku. Takže jestli není problém se slimáky.
There could be. Each farm, each crop, each region is context specific and has its individual challenges. That may mean you have to do light incorporation, some space between. How do you mitigate against snails? And there may be biologicals, I don't know. I live in a more dry area, I don't have that. But there might be ways to accomplish that. But that's where our imagination has to engage this. Otherwise, we continue to destroy. There was another question in here, I think.
Dobrý den. Já bych se chtěl zeptat, když se hnojí hnojem, jak se s tím pracuje, s tou metodou, protože když ten hnůj nechám na povrchu, tak hrozně těch živin a dusíků z toho uteče do vzduchu, když se nezapraví hloubš.
The best on manure actually is to compost it. That's more labor and cost intensive, I understand. Manure actually, in its raw form, kills a lot of the biology, so it pushes your system back before it recovers. So it's a shock, and it's not good. And eventually it recovers. And so if you have manure, how do you get it to be an asset and not slow you down before it comes back in the system? So manure management is a big issue, I know, for many farmers. And don't have a clear answer. I'd have to see your situation and think about it. But I'd want to change just spreading it because of runoff and because of intensity. And the nitrogen itself will repress the biology. After it breaks down, then it recovers. But it's sort of like pushing it back and giving it time to recover. There's a way to manage it to reduce that so you don't shock the biological system and you won't have as much runoff. Great. If you don't, then buffers, I guess, are the best thing to save from the runoff.
So,
one more if you have time.
Jednu poslední otázku, prosím, a pak si odchyťte Timothyho v sále.
Děkuji. Dobrý den, já jsem se chtěla zeptat na problematiku plevele. A ještě ty 364 dnů kořeny, to znamená, že máme udržovat 364 dnů v roce kořeny znamená přesně v zimním období dělat co? První otázka je plevele v no-till principu a potom ta druhá, tedy 364 dnů kořeny v zimě, tedy máme mít nějaký, prostě vysvětlit. Děkuju.
So in the winter you'll have a multi-species cover crop that you will have planted when you had no weeds in your field, and it will compete to repress weeds. And it will have a deep root by spring, and it will outcompete your weeds usually. But honestly, I was hoping to get off stage before anybody asked about weeds. It's context specific, and we could talk about it later. I've seen some ingenious farmer innovations, like in growing soybeans in Indiana, very cold weather in the winter. The farmer planted multi-species cover crops with winter rye. In the springtime, he didn't cut it, he didn't roll it down, he just directly planted seeded no-till soybeans. 6 weeks later, the soybeans were this tall, and then he rolled the rye down. He had enough biomass to repress weeds by that time. And the soybeans stood back up, and he got great yields, no weeds.
So you said multi-species with winter rye and direct
Multi-species
seeding.
with winter rye.
Right.
By
Soybean.
springtime, only the rye was left,
Okay.
because the rest died in the freezes, the hard freezes.
Yeah.
And then he used the rye as the mat
Suppressor.
to suppress the weeds. We have to get innovative and think more creative than most scientists ever could, and figure the things out with the snails and the manure and the weeds. But when we learn to work with nature, I think we can. Thank you for your questions, and thank you for your commitment to regenerating the planet through your farm, one farm at a time. Thank you so much.